For this first unit, we're going to be talking about parabolas and different parts of a parabola. So today, we are talking about specifically what the vertex of a parabola is and what a parabola looks like. So we're going to do two things, the two things that are listed. Given the graph of a parabola, we're going to be able to identify the vertex and also state if it's a maximum or minimum, which I'll talk to you about those things. And then the second one, given the equation of a parabola in vertex form, you're going to identify the vertex and state if it's a maximum or minimum. So you're doing the same thing, but one of them is going to be with a graph, one of them is going to be with the actual equation. So first, let's talk about what is a parabola and what does it look like. So the parabola, the equation of a parabola is actually called a quadratic function. So a quadratic function is a polynomial with a greatest exponent value of 2. So we're going to have an equation that has an x squared in it, x to the second power. So the biggest exponent is going to be a 2. So it could look something like this. This is just an example of what it would look like. So y equals 2. Let's do a different number. Y equals 3x to the second plus 4x minus 6. So the fact that it has this 2 as the biggest exponent, that's the largest number of an exponent, that means it's a quadratic function. If it's a quadratic function, if we graph it, the graph of a quadratic function forms what's called a parabola. So we're going to look at that in just a second. There are two common forms for a quadratic function. So this is the standard form, and that's the same as the one that I just did. That's the standard form. We also have what's called the vertex form, which we're going to be doing that a lot today, the vertex form. And we'll talk about that a little bit more in just a second. So the quadratic function graphs a parabola, and this is what a parabola looks like. So it's a U shape, either a right side, like an upside down U or a right side up U, but that is what a parabola looks like. It's called the equation's called the quadratic function, and it graphs a parabola. So if you ever hear the word parabola, you know it's a U shape, one way or the other. With a parabola, we have what's called the vertex. The vertex is the highest or lowest point on the parabola. So this is a vertex, and this is a vertex, just depending on which way it's facing. So either the highest or lowest point. The vertex is also called either a maximum or a minimum. If it's at the low end, the word minimum means it's low or the lowest spot. So the low point is called a minimum. So this first one is called a minimum. If it's a high point, so it's at the top of the vertex, it's up high, it's called a maximum. So write that on your notes so you've got that in there. So you've got the minimum is the low point, maximum is the high point. So if you have just a regular parabola with a U shape, it's going to be called a minimum. If you have one that looks like a mountain where it's upside down, it's going to be a maximum. So maximum is a high point, minimum is a low point. And it also says that in your notes. You can see maximum is the highest point, and then it says the minimum is the lowest point on your graph. So what we're doing today is you're going to identify what the vertex is, and you're going to also identify if it is a maximum or minimum. So before we do that, I'm going to review looking at a graph and finding points on a graph. So this is kind of a little side note. So if you'll just watch this for a minute to make sure you remember this. If you were in here last quarter, we did stuff like this. If you weren't, then you'll understand after we get done. When we graph things, our graph has two main axes. So this is the x-axis, this is the y-axis. In a graph, we can have what's called an ordered pair or a dot on the graph, and that dot is represented by what's called an ordered pair. So if I put a dot, let's say right here on my graph, so that dot, if I wanted to name that dot or tell you where it was using numbers, I always start at the middle of my graph. So the middle is this point right here that I've got highlighted in yellow. I would start there, and I would always count to the right or left first, and then up or down. So the ordered pair looks like this. It has an X and a Y. The first always moves me left or right, and the second one always moves me up or down. It would be a good thing to add this into your notes, just in that little blank space you have next to where the parabolas are drawn, just so you remember the X goes first and it's left and right, the Y goes second and it's up and down. So it'd be a good idea to write that just off the side of your notes. So the X value is how far we move right. So if I move right this direction 2, then my first number is going to be a 2, and then I move up 1, so the second number is 1. So that ordered pair right there is 2, 1. 2 to the right and up 1. That's that ordered pair. So this said to move 2 right and up 1. So let's do another one. Let's say I have one that is over here in this spot right there. And I want to name the ordered pair. From the middle, where the yellow highlighting is, from the very center of my graph, I move left first, then down. So I move left and down, and I'm just counting how far do I move left and how far do I move down. So I move left 3, which would be -3, and then I move down 2, which is -2. Down is negative and left is negative. If we go up, that's positive, and right is also positive, to kind of keep that, keep those things straight. So let's do another one. Let's say I did one, say I did one right here. I do a dot there, and I want to name what that is. So first I would move left, this direction first, then I would move up from there. So left 1, which is -1, and then up 2. So left 1, up 2. So that's how we name ordered pairs. So that's the first thing we're going to be doing with the parabolas today, is naming the vertex using an ordered pair. Then we're going to just state if it is a maximum or a minimum. So let's go to number 1 on your notes. The directions say identify the vertex of the following parabolas and state if the vertex is a maximum or minimum. So we're naming the vertex, then we're going to say if it's a maximum or a minimum. First thing you're going to do is just draw a dot where the maximum or where the vertex is. So you can see right here, that's my vertex. I need to count how far I move right or left first, then up or down. So if I start at this center, at the center of my graph, I'm counting right and down. I'm just counting how far I move right and down to get to that dot. So I moved over 1, 2, 3. So my first dot or first number is a 3. Then I moved down 1, 2, 3, 4, 5. So my second number would be -5. Right is positive, down is negative. So I moved right 3 and then down -5. The first number is always right or left. Then I look at it. If it is shaped like this, it's a minimum. And if it's like this, it's a maximum. So it's the vertex is down low. It's kind of in the valley in the bottom of the U. So this is a minimum. And we just use MIN. You can abbreviate with just MIN for minimum. And that's all. That's number 1. So number 2, vertex first. I'm going to just look at the graph and put a dot either at the high point or low point. So there's my vertex. Then I'm going to count right and then up. So I need to know how far I moved to the right and how far I moved up. So I'm going right 1, 2, 3, 4, 5. So vertex is 5 and it moves up 1, 2, 3, 4, up 4. So 5, 4 is my vertex. And remember, if it looks like this, it's a maximum. If it looks like this, it's a minimum. So it is a high point. So this is a maximum. Number 3, here's my vertex. And then I just need to count how far I go right and then down. Always move right or left first, then down. So I move to the right 1. So my first number is going to be a 1. Then I move down 1, 2, 3. Second number is 3. So my vertex is 1, 3. If it's a maximum, if it's shaped this way, a minimum this way. So this is a minimum. Anytime it's down in the valley, a U shape, it's going to be a minimum. One more, number 4. So first, just put a dot at your vertex. Then we're going to count left and then down. Always move left or right first. Always move left or right first. So I move left 2, so that's -2 because I'm moving to the left, and down 1, which is negative because I'm moving down. So -2, -1 for that vertex. Then I need to say if it's a max or min. It's a max if it's facing this way, min if it's facing this way. So we have a maximum. Okay, so that is what you do if you are given the graph of the parabola. The next side, so go ahead and flip your paper over. We're going to be given the equation of a parabola, and we still want to find the vertex and if it's a maximum or minimum. So we're finding the same things, but we're going to use the equation this time. So when you have a quadratic equation or a parabola equation in vertex form, that's what we're going to be using here. This is vertex form. This is what it looks like. The A, the H, and the K are going to be numbers. Those three are going to be numbers. The X and Y stay X and Y. But there's going to be a number where the A is, the H, and the K. The H and K, these two, are going to be your vertex. So whatever numbers are here and here, that's going to be the X and Y of your vertex. So the H goes first, the K goes second. So whatever's in the parentheses is your X value. The first number, whatever's outside the parentheses is your second number of your vertex. So that's how we're going to find the vertex. Then the A value helps us determine if it's got a maximum or minimum. If A is greater than 0, meaning if A is positive, so write that down. If A is positive, the parabola opens up and it looks like this, which means I'm going to have a minimum. If A is less than 0, which means it's negative, so if A is negative, again, write that down. So if A is a negative number, that means it's going to open down. It's pointing negative. So if it is negative, the arrows point down, negative. If it's positive, the arrows are pointing up. So if the arrows are pointing up, this is going to be a minimum. If the arrows are pointing down, it's going to be a maximum. So first thing you have to decide is it pointing, what's the shape? Are the arrows pointing up or down? Then you can decide if it's a maximum or minimum. So let's go ahead and do all of that. You do have this on there that just gives you an example if you want to refer to that, but we're going to just go ahead and do number 5 and we'll do exactly what it says in that box above. So identify the vertex of the following parabola, state if the vertex is a maximum or minimum. We're also going to find out what the A value is. So the vertex, we use these two numbers for the vertex. The only tricky part with this, whatever's in here, do the opposite sign. So write this in your notes so you've got it written down. The opposite sign, change positive to negative, negative to positive. And you only do that for the number that's after the X that's inside of the parentheses. So the vertex is going to be, instead of a 1, it's going to be -1, and the outside is a +3. It stays a +3. So these two numbers, this comes from here, this comes from here, but we do an opposite sign on the 1, but not on the 3. The 3 stays whatever it is. The A is this number right here. So A is, this is A, is -4. Because it's negative, that tells me that it is pointing down. So it's going to look like this. On every one of these, I want you to draw the parabola just like I just did, so I can see that you know what it looks like before you answer the next question. So A is -4, which means the parabola is opening down. The arrows are pointing down, which means the vertex is up here. So the vertex is a maximum because it's up high. It's on the top part of your graph. Let's do another one. So number 6. First, our vertex. These two numbers are my vertex, but I have to change this sign. So opposite sign on this one. So just like on the last one, that one we changed the sign. It's a -5, so I'm going to do a +5, but the 4 is going to stay whatever it is. If it's positive, it stays positive. If it's negative, it stays negative. Then I have the A value. So this is A right here. I'm going to write 2/3. I don't care what the number is. All I care about is it positive or is it negative? Since 2/3 is positive, the parabola is opening up. It's pointing positive. If it's negative, it points negative. If it's positive, it points positive. That means I'm going to have a minimum because the graph has a low point. And I want you to draw this on every problem so that I can see that you know which way the graph opens. Number 7. So first thing, our vertex. So here's our vertex, these two, but we're going to do the opposite sign. So a -6 turns into a +6. The 2 is going to stay negative. Do not change the sign on the 2, just the 6. The number in front here, if there is no number here, just like what we've done in the past, there is a 1 there. So go ahead and draw a 1 on your paper right there. And the A is going to be 1. So you're going to write a 1 in that spot. It is a positive 1. We don't care what number it is. We just care that it's positive or negative. It is positive, which means my graph is pointing positive. Up is positive, so it's pointing in the direction that the positive direction because the number is positive, which means I have a low point, so I have a minimum. Number 8, vertex first. This is my vertex, these two numbers. I do the opposite, so this is going to be a negative 10, but the 6 stays exactly the same, so it stays positive 6. The number in front, negative 2 over 5, is my A value, so I'm going to write negative 2 over 5. Because it is negative, my graph is pointing negative. Again, I want you to draw this on every problem. I want to see that on your paper. So it's pointing negative, which means I have a high point on my graph. The vertex is a maximum. Number 9. This one's kind of tricky because I don't have a number out here. I'm missing a number. If there's no number at the back, what I have to do is think of what would I add to not change the value of this. If I add a 1, it changes the value. But if I add a 0, if I add 0 to something, it doesn't change it. Like if I do 5 plus 0, it still equals 5. So adding 0 does not change the value of my equation, but it just gives it a number to be there. So if there's ever a number at the very end that's missing, you're going to put a plus 0 there. Then these two numbers will be my vertex. I need to change the sign to a positive 2. The 0 is just 0. Then I have a negative 3 as my A value. So I'm going to put a negative 3, which means my graph is pointing negative. It's pointing down. That gives me a high point on my graph, which means I have a maximum. Number 10. Again, there's a missing number back here. If you have a missing number in the back, we're going to put a plus 0 in that spot. The vertex would be these two numbers. Change the sign on the 15, so it's going to be negative 15, 0 for the vertex. The A is this number in front, so A is just 20. It is positive 20, so my graph is pointing up because it is positive 20, which means I have a low point on my graph, so I've got a minimum. Okay, these last two have one more thing that's a little bit different. You'll notice we have this minus 2, but with the x, there's a missing number. So really, this should look like this. And I want you to write this off to the side. So y equals negative 4 over 7. And we should have something in parentheses squared with the minus 2 outside. So you'll see that what we're missing is the number in the parentheses. Just like above on the last two questions, if you have something missing inside the parentheses or outside, you're going to put a plus 0 in that spot. So if anything's missing, and if you will rewrite it, I want you to write this down. So write this on your paper. This is what the equation would look like. That will make it easier for you to find the vertex. So my vertex is using these two numbers. So it would be 0, and 0 is not positive or negative, so just put 0. And then the 2 is going to be a negative 2. The number in front, this negative 4 over 7, is still my A value. So I'm going to write negative 4 over 7. It is negative, which means it's pointing down, which means I have a high point, which is a maximum. All right, last one, number 12. Again, we have this 3, but we're missing the number inside of the parentheses. The parentheses aren't even there. So I'm going to write y equals 6, and then I put my parentheses, and the square is outside, and I have an x plus 0 inside of there. So that x turns into an x plus 0. It doesn't change the value of it. It's the same value. We're just putting a placeholder or a number there. So those two are my vertex, so 0, 3. And then the number in front, 6, is my A value. And I don't care what the number is. Again, I just care that it's positive. If it's positive, my graph is pointing to the positive direction, which means I have a low point, so I'm going to have a minimum for my vertex on this one.